We are looking at, look at that. It's our favorite math F word, right? Factor. All right, we get to factor today. So we not only get to do trig, but we get to factor in the trig. Doesn't that sound super exciting? I know I'm really excited about it, okay? So any algebraic operation that we can do it with trig embedded in it, okay? You have to treat the piece of trig like a variable, okay, until we do the trig part with it, okay? Until we do the Pythagorean identity, or we do a reciprocal identity, or we do a quotient identity. Until we can do one of those replacements, you treat it like an x, okay, or you treat it like a y, okay? All right, let me find my cheat sheet on this. Okay, so that first one there, what's our very, very, very first rule of factoring, you guys? What do we look for? Greatest common factor. So let's look inside of that group right there. Okay, so I've got the yellow part of the group and the purple part of the group. What do they have in common? Secant squared x. That would be my greatest common factor, right? We're looking for GCFs. So I am going to pull out secant squared x. I'm pulling that out front. Okay? So just like any other greatest common factor factoring we have done, what would be left behind in the yellow group? Tangent squared x. Good. Then there's a plus sign. Technically, there's always what number out in front of everything? 1. So what's left behind in the purple group? 1. Okay. That wasn't terrible. Okay. Wasn't so bad. All right. Here's what I want you to do next. Okay. That looks like something that might be up on our pink sign over there. So would you look at the pink sign and see if you can find something to replace tangent with, or tangent squared plus 1 with. Okay. Was he not here yesterday? All right, did we find something? Write it down. Write it down in there. I'm getting these out. Okay. Okay. Let's see. What did we find on the sign? What can we replace it with? Look up there. What can we replace tangent squared plus 1 with? Good. Okay, so everybody's looking up at that sign the same way. And what I'm going to do is I decided I'm going to put all the identities you need. I'll make sure that they're embedded in each question on the quiz. Okay, so that way you've got those. We now right now have them in our notes, right? I'll try to get my signs back up there too, but you have them written all in the notes somewhere. Okay, but we will make sure they're in the quiz, so you don't need to worry about memorizing them. Okay, so I'm on that sign. I'm in the first column. I'm in the second row. Okay, so first column, second row. Everybody sees it? 1 plus tangent squared equals secant squared. So I'm allowed to replace this with secant squared x. Okay. This other piece, I'm just dropping down secant squared x. Okay, I want to go back to algebra for a minute. If I have x squared times x squared, what am I supposed to do with the exponents? Add them. So it would be x to the 4th. Okay, I've got secant squared times secant squared. What's that going to come out to be? Secant to the 4th. And notice, the exponent is not on the x, it's on the secant. So when you're doing your homework, and when you're doing an Otis review, and when you're doing the Otis quiz, you're going to have to type the exponent onto the trig, not onto the variable. Okay, and you got to watch for that. And guess what? If it's on the variable, I'm not marking it correct, because I've warned you, right? It has to be on the trig. Okay, any questions about example 20? Okay. Example 21 is pretty similar to example 20. I changed the trig identity just a little bit, but it acts kind of the same way. I want everybody to go through and try 21. Look for your greatest common factor, pull it out, and then look for a Pythagorean identity you can replace with. Okay, I'm going to give you a minute. Everybody try it. does make a difference. You have to make sure the sign matches whatever. It's a minus, you keep it minus, yeah. Unless there's a negative coefficient in front of the first one, then yeah, you don't change it. Okay, let's check it. So I have two groups there, right? I have what I would call the yellow group, okay, and the purple group. What do they have in common? Sine, perfect. Okay, so we're going to pull out a sine. Sine x comes out, okay? What's left behind in the yellow group? Good. Cosecant squared x, and what's left in the second group? -1, perfect. All right, did we look up at the... So anytime I see that, you guys, I see a squared or two squareds and a -1, that is a red flag or a pink flag, right? Because it's going to be on that sign up there, hopefully. The signs have to match exactly. So if this would have been a +1, we wouldn't have been able to replace anything, right? Because we don't have a cosecant squared +1. We only have a cosecant squared -1. Okay, does everybody see it? So it's the bottom row. It's the one in the middle. Okay, so what am I allowed to replace this with? Cotangent squared. Okay, now, this one, if you got that far, that's awesome. Okay, this one can go one step further, I think. Actually, I take that back. I'm going to leave it there. We could mess with it more, okay? Because I think I was trying to remember what I did last night because I was playing with this one last night when I was making up the note page. We could take cotangent. Don't write this down. Just watch. You could take cotangent and make it cosine squared over sine squared, right? And then, like, that sign would cancel with one of these signs. And it would be cosine squared over sine. Does that really do us any good? Not really. I could, if I wanted to, that would be 1 over sine, cosine over sine. And that could be cosecant times cotangent. And I'm not sure that did us any good. So I'm going to let you stop right here. Okay, let's not go further than that one. All right. But say it was an SAT question next year, right? Or a PSAT question. You can still manipulate the trig more to get to an answer that's there. Okay. So in case it's a multiple choice, but I'm going to let you stop right there. 2 lines is good, right? If we can do those 2 lines, I'm happy. Okay. All right. Let's take a look at this next one. This next one is weird. Okay. And like really weird. Okay. Let's review some of our old factoring. Okay. You don't need to write it down. I just want you to watch. Okay. So if I gave you something that looked like this, okay, what would you tell me to do? What kind of factoring? Magic X. Good. So we would need 2 numbers that multiply to 1 and add to -2. What are they? -1, -1, right? And our answer would look like x minus 1 times x minus 1. Okay. Hasn't changed since first semester. Okay. So when I see something like this, count the terms. 1, 2, 3. No greatest common factor. I've got a trinomial. I know it's going to be magic X factoring. Okay. I am, instead of looking at this with signs, I'm just going to rewrite it with X's. Okay. And I'm going to use that to kind of help me factor this thing. Okay. So I'm going to pretend that it's really 2 minus x squared plus x to the 4th. I'm going to use that as a model. Okay. All right. I'm still doing good old magic X. So I need 2 numbers that multiply to 1 and add to -2. What are they? Yeah, we just did that, right? Okay. The difference between these two is, first of all, they flipped where the leading coefficient, the leading term was, right? The highest exponent's in the back and not the front. And do we notice how we switched it to 4th power and squared instead of 2nd power and 1st power? Okay. So that's going to change a little bit how we write this. Okay. Because of it being written backwards, okay, our 1 is going to go up front. Okay. The minus is still going to go in the middle. And then, you know how we take, it's really the middle term is what goes in there. So what's in our middle term right here? X squared. And again, this one's weird. This one's kind of mean. I probably wouldn't be quite this mean on a quiz, I hope. Okay. The greatest common factors 100% are going to be on the quiz. Okay. But I'm trying to show you everything. And you know I don't quiz absolutely everything. All right, so this is the model I need to apply to this one. Instead of writing x squared and x squared, guess what I'm going to write? Sine. Okay, sine squared and sine squared. Okay, so when I factor this, okay, it's 1 minus sine squared x times 1 minus sine squared x. Sometimes we have to make a model for the math problem to make it easier for us to see. And that's what we just did there. We took it to something we knew. Okay. All right. I want you to look up at the pink Pythagorean sign. They look Pythagorean. Go up there. Look, do we see if we have 1 minus sine squared? Find it. Okay. 1 minus sine squared. What is it? Good. So first row, middle column, right? So it's cosine squared x times cosine squared x. All right, what's cosine squared times cosine squared? Good, cosine to the 4th x. It's nice to do something that is familiar, but we have this like new, like challenging twist to it. It kind of helps our brains like be really interested in it again. Okay. All right. Any questions on 22? That one was weird and ugly. Okay. All right. I was trying to make homework problems up for you last night. All right. So looking at example 23. Okay. So let's see. So far we've done greatest common factor factoring. We've done magic X factoring. I'm not going to be mean and make you do a magic X in a box, hopefully. Okay. When I have only 2 terms and they're nice, even exponents there, what kind of factoring do we do? Do we remember? What if I gave you this? Not that. X squared minus 4. Difference of squares. Isn't this the same thing? Square terms, right? Even exponents are squares. So square terms, I'm going to do a difference of squares factoring. Okay. All right. So that's a nice shortcut, right? So I have to take the square root of the first term. What's the square root of secant to the 4th? Good, secant squared. It's no different than taking the square root of x to the 4th, right? We divide that exponent by 2. All right, and that's going to go in the front of both of these. Okay. What is the square root of tangent to the 4th? Tangent squared x. Don't forget to write the x part. Okay, sometimes when I'm thinking, I'll scribble it out without that x, but you have to go back and put in the x to get the full credit for it. All right. In difference of squares, we make 1 a what? Positive and 1 a negative. See, you know that part already really well. That's awesome. Okay, we're just adding the trig layer to it. Okay, now, doesn't it kind of look Pythagorean again? So I need you to look up at the sign and see if you can either find secant squared plus tangent squared or secant squared minus tangent squared. Okay, which one's up there, plus or minus? The minus. Okay, so the minus is in the second row, the second column. It's in the exact middle of the sign. What am I allowed to replace this with? 1. And this first part, we can't replace it with anything, so that's as simple as it's going to get. I do 1 times that, and I just get the secant squared x plus the tangent squared x. Okay? Any questions on that one, on 23? And again, as we're going through these, sometimes there's so few of these I can do that we only have one example of each one, okay? And there's really only like one practice in the homework. There's not a lot because there's so many different types. I tried to get at least one of everything, okay? All right, example 24 is still in the factoring section, okay? Even though it looks like a fraction. I'm going to have to do some kind of factor. I'm going to take that as an indicator. I need to do some kind of factoring to solve it or to simplify it in some way. Okay. All right. Let's take a look at it. So I have a square term and a square term. What kind of factoring should I do? Difference of squares again. Okay, so I'm going to set up for 2 binomials here in my numerator. What's the square root of cosecant squared? Cosecant, good. What's the square root of 1? 1. Good. Make 1a and 1a. Good. And then this denominator is just going to get written down the way it looks. And I'm purposely putting parentheses around it so you can just see it better. All right. That's a good old rational expression. We did those a while ago. I think first semester. What's going to happen? We can cancel. And remember, we only can cancel when there's things being multiplied, right? This counts as the multiplication. We don't cancel over addition or subtraction, or that's us killing the kittens, right? The kitten dies if you kill over addition and subtraction. So these cancel. My final answer, cosecant x plus 1. On this one, why am I not going up and looking at my pink Pythagorean sign? What's missing? Yeah, there's no squared. So I know that when it's that, I know that when everything's in the numerator, I'm done. Okay, so I don't want to go any further. That's as simple as it's going to go. Okay, and the homework assignment, so you can practice these, is Otis. So there's a check answer button. And you can check it as many times as you need to try to keep getting the answer as simple as possible. Okay, all right, let's take a look. Any questions on 24? So we're going to shift gears a little bit here. We're going to switch to a different type of operation. Okay. So now we're moving into lots of different operations on these. It says perform the indicated operation and use the fundamental identities to simplify. So the first thing we're going to do is the algebra, and then we'll do the trigonometry. Okay. So looking at that, I have a binomial times a binomial. What do we use? Let me do this. X minus 2 times x plus 2. Distributes part of it. We've got a better name for it. Oh my. How would we do this? Yeah, we'd have to FOIL it, you guys. We're foiling. Okay, now, let's see if we... Actually, we're going to FOIL all the way. I'm not going to try to do the shortcut. I'll remind you of the shortcut at the end, okay? All right, so I'm going to do my first. What's tangent of beta times tangent of beta? Good. I like that we put the squared on the tangent. Tangent squared beta. So the squared goes on the trig, not on the beta. Okay. All right. Now I'm doing the outside. So I've got tangent of beta times negative secant beta. So I would go negative tangent beta secant beta. All right. I'm going to do the insides. And that's secant beta, tangent beta. I'm going to write it the other way. I'm going to go positive tangent beta, secant beta. And then finally, we're going to do the lasts. What's secant beta times negative secant beta? Negative secant squared beta. Good. Okay. I want to remind you of something. Okay, and this is a nice shortcut if you can remember it. If you can't, that's fine. Do it this long way. Okay? Look at the middles. What's happening? They're the same, but what? Different signs. What's going to happen? They cancel out. Remember when we talked earlier this year about conjugates? And if we have conjugates, meaning it's the same expression, same binomial, but opposite signs, that the things would cancel. And if you're foiling, you can shortcut it and just skip doing O and I and just do first and last. You could have done that on this one had you recognized it. Okay. If you didn't, this works. Okay. All right. So our answer right now is tangent squared beta minus secant squared beta. And here comes a really big hint. Okay. On these problems, if I have yet to apply a trig identity, I need to make sure I do that. Okay, because we wouldn't be testing you on the new stuff if I didn't have you apply an identity. Okay, so look up at the pink Pythagorean sign. We're looking for tangent squared minus secant squared. Is that one up there somewhere? Oh, it's not. Okay, but I'm going to get it fixed so that it is. Okay, look at the one in the middle, right? Very middle of the sign. It says secant squared minus tangent squared. So what's wrong with these signs? They're flipped. Is there an easy way to flip the signs the other way? Multiply by -1 or factor out a -1. So I'm going to do that. I'm going to factor out a -1. At the same time I'm doing that, I'm going to switch the order. So when I take a negative out of this, it's going to become negative tangent squared beta. And when I take a negative out of this, it's going to become positive secant squared beta. Now, is it the same as what's up there on the sign? Yes. Okay, so if you can do that, and it's as simple as just factoring out a negative, you want to do that. Okay. All right, so I have -1 times what? What do I get to replace with? 1. What's -1 times 1? -1. All right, any questions on 25? I'm going to try to get through the notes today, so we've got a good whole period to work tomorrow. Okay, that's the goal right now. All right, let's look at 26. I want you to try 26. Get as far as you can. You don't have to finish it. Just at least get the FOIL part done. See if you can do the FOIL part. Okay? There might be a GCF later too. So FOIL, see if you can find a GCF. Maybe, I don't know. Maybe there's not. I think that this is set up to have a GCF. Okay, let's take a look. I started it. I did my FOIL piece, okay? So I got 9 secant squared x. And then on the outsides, I got -9 secant x. On the insides, I got -9 secant x. Not opposite signs this time, though. And then -3 times -3, I got +9. Are we all okay? Any questions on how I got that? I'm going to combine like terms next. And my like terms are these guys in the middle, right? These guys get to get put together. So again, we're doing the same algebra we've done since algebra 1. We're just instead of putting an x there, I've got a secant x there. Okay. So the middle, I would get -18 secant x plus 9. All right. It's looking like I'm going to be able to do a magic x on it, kind of, but I absolutely do not want to deal with a leading coefficient, right? So what's my greatest common factor? 9. So we're going to pull that 9 out front. That hopefully will help us. So secant squared x minus 2 secant x plus 1. Okay. If it helps you, because that, I know it's a trinomial. I know it's got 3 terms. I know I'm probably going to be able to do a magic x. If it helps you to think of it like this, then think of it like that. It's fine. Remember, the only person who sees your work besides you is me. And that's what we want to have happen, right? It's between you and me. Okay? You can show me you can do this. All right, so I've got 1 and -2. What numbers are going to go in there? And it's not always going to be this one. We've done that one like 3 times, right? It's not always going to be that one. All right, so if I was doing this problem, I would go x minus 1 times x minus 1, right? Instead of x, what am I going to write for this problem? Good. So I'm dropping down my 9, and I've got secant x minus 1 times secant x minus 1. I'm not sure that did us any good. Because it can't be tangent, right? Because look at what's missing off of it. The squared. I don't have the squared. Had it been like a 4th power and a squared here, I could have done something with it. Now, there's one other move I could make, okay? Remember, these are the same thing, right? I could be super cool and write it as secant x minus 1 squared. Remember, that doesn't mean distribute it back in, right? That means write it twice, which basically reverses what we just did, Okay, so when the squared's on the outside like that, it just meant that we had it written twice. Okay, that's as simple as we could get with that one. Not all of them are just going to be a 1 or a cosine or a sine, and that's okay. Any questions on that one? That one was yucky. Okay, I thought it looked better than it was. Okay, all right, let's look at this one. We got to do some fractions with some addition here. That's not the button I wanted. This one. Okay, we're reviewing all the algebra we did all of first semester in just this one lesson right here. Isn't that great? Okay, so what operation are we doing on this one? What's the operation? Okay, we're going to get there. What's the operation between the two? Subtraction, okay? But I really like what he said. He said that lowest common denominator, right? Because I've got fractions that I'm adding. So remember when we circled in blue what matched and underlined in red what didn't? Those are the underlines and reds because we're going to have to use them both. Okay, so I'm going to start by setting up my common denominator, which would be secant x plus 1 times secant x minus 1. And we did a lot of shortcutting, okay, when we were doing this. We basically need to multiply top and bottom by the missing piece, okay? I've already taken care of the bottom. So looking at this denominator and comparing it to my common denominator, what's missing? What's different from this one to this one? The subtraction. So I'm going to multiply by the subtraction one. I'm going to multiply by secant of x minus 1. I'm distributing positive 1, which means I get secant x minus 1. All right, I'm now going to compare this denominator to my common denominator. What's missing? The plus 1. Okay, so I'm going to multiply by secant of x plus 1. All right, what are we going to do with that? Distribute in a negative 1. So it's going to change my sign. So negative secant x minus 1. Okay, again, we're relying on the algebra we learned before. Look at your numerator. What's the next step? Combine like terms. What happens with secant x minus secant x? Cancel, right? What's negative 1 and negative 1? Negative 2, good. And then I am keeping, I'm going to do a little bit of I'm going to simplify that denominator. Remember how we talked about conjugates a minute ago? Okay, so are they conjugates of each other? Yep, so I'm going to shortcut it and just do first and last. I'm going to multiply it out. Okay, so what's secant x times secant x? Secant squared x, good. My O and my I would cancel. What's 1 times negative 1? Okay. Look up at the pink Pythagorean sign. Why did I do that? What's that? What did that give me? It gives you tangent, right? It's the second row, last column. It gives you tangent squared. Am I allowed to leave it in the denominator? I got to bring it up, right? So when you bring it up, what's the reciprocal of tangent? Not sine over cosine, that's quotient. Cotangent, so it should be negative 2 cotangent squared. Write that down while I'm getting the phone. Negative 2 cotangent squared. They'll call back. They should just, see, I told you they would call back. Plus $1. Yep. Ariana, you're leaving. Okay, everybody got it? Negative 2 cotangent squared, we got it? Wrote it down? Okay. How we doing? We're doing good on time, okay? I think we can finish. We've only got 2 examples left. And then I promise tomorrow, no examples, okay? Might as well get it done today. All right. That's what we've got. All right. Any questions on that one? And I know we're doing one and it's and we're done and we're moved to the next one and it's a little bit different, okay? All right, let's look at 28. Okay, 28's kind of similar. It's got a fraction again, right? Uh, is the common denominator kind of the same thing? Do either one of them match? No, so I'm going to need them both in my LCD, right? Because it would be an underline in red and underline in red. I need them both. So 1 cosine x times 1 minus cosine x. Okay, we're looking for missing things, right? So I'm looking at this and I'm comparing it to this. What's missing? Yep, so we're going to multiply by 1 minus cosine x. What's instinct tell you to do with this? Distribute. Okay, it's not quite a FOIL because it's a monomial times a binomial, but same idea, right? Distribute and FOIL are really the same thing. Okay. All right, so I've got sine x, and then these are, I'm just going to multiply them together. Negative sine x, cosine x. It doesn't matter what goes first. My brain works with sine going first, but it doesn't matter. You pick your favorite order. Okay, I'm now comparing this denominator to this denominator. What's missing? Yep, 1 plus cosine x. All right, this time there's a plus sign in between, so I just am distributing a positive. So plus sine x, and then plus sine x cosine x. All right. What happens in the numerator there? Okay, I heard canceling, right? I get to cancel these two. What's 1 sine plus 1 sine? 2 sine x, good. Could I do a little first and last on the bottom? I'm going to FOIL, but they're conjugates, so I'm just going to do first and last. So it's 1 times 1. 1. Cosine times negative cosine. Negative cosine squared x. Okay. Pythagorean, go look up at the sign. Okay, what do I get to replace 1 plus minus cosine x with? Good, sine squared. So 2 sine x divided by sine squared x. Whenever I have something squared, how many times am I allowed to write it? Twice. So if I just split that up as sine x times sine x, what happens? I can cancel one of the signs. Could I have done my subtract the exponents thing? I could have done that too. I was just trying to make your brain not hurt as bad as it does right now. Okay, because I'm sure we're getting really close to that, right? All right, I've got 2 over sine x. Am I allowed to leave a denominator? No, what's the reciprocal of sine? Cosecant. You guys are getting really good at this. That's a lot faster than it was a month ago, you guys. Got one more to do. One more. This is my favorite problem all year. Gotta stay for my favorite problem. Yeah. This is like, I absolutely love this problem. That's why I leave it in there. Okay? Because look at this. Not only do we have, whatchamacallit, trig, we've got logs. Doesn't that sound exciting? I am so excited by this. Okay, so let's do it really quick. It'll take us like a minute and a half if we go quick. Okay? You can wait 1.5 more minutes. All right. So back to our log stuff. Okay? When we have addition, what does it turn into? You know this. Not subtraction, multiplication. So I'm going to go natural log, absolute value of cosecant theta times tangent theta. Now we're going to look at the insides there. I'm going to try to rewrite it like we were doing yesterday. Cosecant is the same as 1 over sine. Tangent is what over what? Sine over cosine, right? What happens with the signs? Cancel. So I have the natural log absolute value of 1 over cosine theta. What's 1 over cosine theta? What's the reciprocal? Not sine. Secant. Good. Okay. Not so bad, but that's an awesome problem. I love the fact that we can put all the algebra we have ever done, we can throw trig into it. Okay. Yes, you can. Let me put it in. Okay. All right. We're gonna hold off. I haven't assigned the homework on this piece yet. Make sure you've done the 2 old ones. We're gonna work on this homework in class tomorrow. Okay. So that's what that's where we will put it. Okay. Remember tomorrow we're also gonna do the you can go. We're gonna do the unit circle thing in class. So you could work on the radian thing again if you wanted, or you could work on the previous 2 homework assignments right now. And we will do this homework assignment with this part tomorrow when we come in. And that'll be all we do besides the unit circle quiz tomorrow. Okay? And you'll have my support to help out, right?
Can you go to the restroom when she gets back?
Yeah, I need your ID.